Welcome to our deep dive into the mystical world of SPL tokens using the Anchor framework. In this video, we'll embark on a journey to uncover the inner workings of a token program on the Solana blockchain. We'll walk you through each line of code, explaining the powerful spells, functions, and enchanted contracts that bring our token system to our life. By the end of this video, you'll have a clear understanding of how to create, mint, transfer, and burn tokens using Anchor and SPL. Okay, so grab your spellbook and let's begin this magical adventure. In the mystical world of blockchain, we begin by invoking the essential powers from the Anchor and SPL libraries. These imports are the foundation spells that empower our program with the capabilities to manage tokens. Okay, so the code looks like this. Firstly, we had imported all functionalities from Prelude from the Anchor_lang. Thereafter, we had used the associated token imports from Anchor_SPL package. And also we have used self burn mint2 token account transfer from token section of Anchor_SPL package. Thereafter we have the declare_id. This basically defines the program ID of our program type. So with these invocations, we have equipped our spellbook with the tools needed to manipulate tokens. The program ID acts as our magical signature, uniquely identifying our program in the blockchain realm. We now delve into the heart of our program, where the core spells are cast. These spells defines the main functionalities of our program. So first of all, we have the program derivative, which defines the core magical module of our program. This is the heart where all our token operations are defined. Now, we bring in all previously summoned imports into our main module using the use super. The create token spell is one of the most integrated. It initializes a mint and conjures the initial supply of our tokens. In this function, we have few parameters: the secret context containing all necessary account for the spell, the number of decimal places for the token defining its granularity, the initial supply of tokens to be minted representing the first conjuration of our new currency. Now, we just output the result of our function. Our spell returns a result type indicating success or failure. Now CPI_accounts will prepare CPI accounts for initializing the mint, which is birthplace of our tokens. CPI_program takes the program account, that is a critical component in our spell. Thereafter we have CPI_CTX, that's context, which basically creates a CPI context, a magical conjure for our CPI invocation. Thereafter we have token for initialize mint, which invokes the initialize mint function to set up the mint with the specified decimals and authority. In here, we are passing four contexts or four parameters, which are CPI_context, and thereafter we have decimals, we have the pairs key that acts as the mint authority, we have the pair also holds the freeze authority. Okay, now we have the CPI_accounts, which prepares CPI accounts for minting the initial supply of tokens. In here, we have three of parameters that are mint, to, and authority. These are the account info of each program and owner. Here, we are creating the CPI context for minting tokens. Thereafter, we are summoning the mint_2 function to create our initial batch of token, and now we are returning success using this OK keyword, indicating our spell is complete. Now, let us have a look at our next function, that is mint_tokens. After creating our token, we need to mint it. So this will be our secondary spell for minting additional tokens. This will allow us to expand the token supply as needed. Now, in this mint_token function, we are just passing a context mint tokens with the amount as an unsigned integer. And here we are passing the result, and we have the CPI_accounts, which gives the mint to and authority programs for our mint token functionalities. Thereafter, we have the CPI_context that basically defines the context for our mint functionality, and then we are just performing the mint_2 operation on the defined context with the amount. In last, we are performing the OK statement for returning the result as a success. So this is how we can declare the mint_tokens function. So now let us have a look at our third function, that is transfer_tokens. It is a spell to transfer tokens from one account to another, facilitating the movement of one currency. So in this function also, we had just two parameters, that is the context of transfer tokens and amount, which is as unsigned integer. Thereafter, we are just passing the result, getting the result And in here, we have the same things such as the CPI accounts, which takes the token transfer as parameter and puts out from, to, and authority programs for the functionality. Thereafter, we had defined the CPI underscore context for this function, and then we are saying the token transfer function for the transfer of the tokens. Thereafter, we are just returning out the success using the OK keyword. Right, so there we are. We have our last instruction, that is burn underscore tokens. It is basically a spell to burn tokens, reducing the supply and allowing the controlled deflation of our currency. In this token also, we have two parameters, and we are just putting the result up here. And we have the same as CPI accounts, in which we have mint, from, and authority programs. After that, we have CPI underscore context, which basically defines the context for the functionality of burn by taking the account info of the token program and CPI accounts. Now, lastly, we just burn out the tokens using the burn function by passing the CPI context and the amount. And there we are putting the OK as a success of our function. In this module, we define the main spells of our token program. The create underscore token function sets up the mint and conjures the initial token supply. The mint underscore tokens function allows for the creation of additional tokens, while transfer underscore tokens enables the movement of tokens between accounts. Finally, the burn underscore tokens function reduces the token supply by burning a specified amount. Now, are enchanted contracts known as accounts structs. These define the necessary components for each spell. They specify the accounts required, ensuring that all participants have the correct permissions and attributes. Now, let's see our code. In here, we have defined 4 public structs. Those are create token, mint token, transfer tokens, and burn token. In the create token, we basically define the accounts needed for creating a token. This struct initializes the mint and associated token accounts and includes other essential programs. So first of all, we basically derive it from the accounts global variable, and thereafter we are giving it another derivative account, which we are passing init, pair, and space for the program. Thereafter, we have the public variable mint, which just basically takes the info of account. Now we have the account derivative for the token underscore account, in which we also pass the init, pair, and associated token for the mint and associated token for the authority as a pair associated token account tied to our mint. Okay, so thereafter we have the mutable access to the pair using the derivative account mute, and thereafter we have several public variables such as pair, system program, token program, associated token program, and rent with their specific types. Right, so this was our create token struct. Then let's go ahead over the mint tokens struct. In this, we basically define the accounts needed for minting tokens. This struct includes mutable mint and token accounts, the authority, and the token program. So we are just declaring the mint tokens and giving the lifeline to the information. Thereafter, we are just using the account mute derivative to grant the mutable access to the mint account. We are just declaring the mint account using the pub keyword and account context. Right. Thereafter, we are declaring 2 authority and token underscore program variables with the specified informations. So now let's move forward to the transfer tokens struct, which basically defines the account needed for transferring the tokens. This struct includes mutable from, to, accounts, and authority, and the token program. In this struct, we basically derive it also from the accounts, and thereafter we are just declaring it as pub struct with a lifetime of info. And here also we have the derivative of account mute, and then we are just declaring the from, to, authority, and token underscore program, which takes the data types such as signer, program, account with the dedicated lifetime and information. Right, so there we are at our last struct that is pretty useful to reduce the quantity of the tokens. Right, so this account is needed for burning the tokens. This struct includes mutable, mint, and from accounts, the authority, and the token program. We are just derivating it as we have done for others from the account, and thereafter we are just declaring the burn token struct with lifeline info. Right, thereafter we are just declaring the account mute as done upper, and then we are declaring mint, from, authority, and token underscore program with data types and contexts such as account, signer, program with lifelines and data. Right, now each struct meticulously defines the necessary accounts for each spell, ensuring that our token operations are secure and precise. By carefully crafting these enchanted contracts, we establish a robust framework for managing our tokens within the blockchain realm. Thank you, wizards, for joining us on this enchanted journey through the SPL Token Program using the Anchor framework. We have explored the core spell that allow us to create, mint, transfer, and burn tokens. And we have examined the enchanted contract and ensure our token operations are secure and efficient. In our next video, we'll delve into the practical side of things. We'll show you how to interact with these smart contracts, bringing the theoretical knowledge we have covered today into the real-world applications. But if you want, you can try to test this smart contract and interact with it on your own. This could be your homework. Yup. Okay, so don't miss it. Stay tuned for more blockchain wizardry. Until next time, keep your spellbook handy and your blockchain knowledge sharp. Happy coding!